Alright, continuing with building equations. The first two examples gave you a slope and a point, and now the examples are just giving you 2 points. So this is a little bit longer of a procedure. The first thing you want to do is find the slope, which we practiced in section 8.4. From there, you want to pick a point. And it's totally up to you which point you want to use. They're on the same line, so it's up to you. And then do the same thing we were doing for the first two examples. Use point-slope form to get your equation built. And pay attention to what finished form they want. And again, this is the second part. That's the end of the procedure. Alright, so let's find the slope between these 2 points. We're going to do 4 minus 0 over 5 minus 3. 4 minus 0 is 4. 5 minus 3 is 2. 4 divided by 2 is 2. So a nice clean slope. Then we're going to pick one of the points, and it's totally up to you which one you want to pick. I like working with zeros because it makes it a little easier, so I'm going to pick this point. You can pick 5, 4, you'll get the same answer at the end because these 2 points are on the same line. So I'm going to pick this one for my point, and I've got my slope of 2. I'm going to put this into point-slope form. Oops. Blank times x minus box. So I'm going to plug in what I have. My slope is 2. My x value is 3. My y value is 0. So I like working with positive numbers, and I like working with 0. So that just makes your job a little bit easier. So we'll distribute that to y minus 0 is just y equals 2x minus 6. We're in slope-intercept form. It's asking for standard form, so we will subtract 2x from both sides. That's going to give us negative 2x plus y equals negative 6. And then we just need to fix that leading negative by multiplying everybody by negative 1, including the 6 over here, for our final answer of positive 2x minus y equals positive 6. So there's my equation in standard form. So again, you find the slope, which we should be able to easily do. You pick a point, doesn't matter which one, whichever one looks easier to you. You use that point and the slope you found to plug into point-slope form, and you follow the same procedure as above. Let's look at another example here. It says write the equation of a line through the points 8, negative 4, and yours should say 5, 5. I had a typo on mine, but it should say 5, 5 in slope-intercept form. So again, the first thing we want to do is find the slope. So that's going to be 5 minus negative 4 over 5 minus 8. So that's going to become 5 plus 4, which is 9, over 5 minus 8, which is negative 3. And 9 divided by negative 3 will be negative 3. That's our slope. Then we're going to pick a point. We have 8, negative 4, and 5, 5. I like positive numbers, so I'm going to pick 5, 5. And we'll plug it into point-slope form. Y minus box equals blank times x minus box. We're going to plug in our 5s, plug in our slope of negative 3. Then we'll distribute y minus 5 equals negative 3x. That's going to become plus 15. From there, we'll move the 5 to the other side. Y equals negative 3x plus 20. And it wants the final answer in slope-intercept form. Remember, that's our second part. That's our finished form. And it's in slope-intercept form. So we're done. So we're finding our slope. Usually that's an integer, sometimes it's a fraction. We're picking one of the 2 points arbitrarily, whichever one you like. Plug it into point-slope form, crank out the answer, make sure your final answer is in the same form it requests at the end. A few more examples here. So we have write the equation of a line through the points 8, -3, and 4, -8 in standard form. You can try this one on your own if you like, or you can just follow along with me. Let's find our slope. That's going to be -8 minus -3 over 4 minus 8. -8 minus -3 is -5, and 4 minus 8 is -4. The negatives cancel, so we're left with a slope of 5 over 4. That is our m. We're going to pick one of the points to work with. Here they both have a negative. I like even numbers, so I'm going to pick this one. If you picked the other one, that's totally fine. Your work will look different, but your final answer will look the same. So from there, y minus box equals blank times x minus box. Let's see, our slope is 5 over 4. Our y value is -8, and our x value is +4. So y minus -8 is really y plus 8. Equals 5 over 4 times x minus 4. Anytime your slope is a fraction, I recommend killing the fraction just so that it's easier to work with. Multiply both sides by that denominator. On the right, it just cancels the denominator. On the left, we actually distribute. So we should get 4y plus 32 equals 5 times x minus 4. The numerator does not change. You can distribute right there or right here, whichever you're more comfortable with. So I'm going to bring this up over here. 4y plus 32 equals 5x minus 20. Always move your constants to the right. So 4y equals 5x minus 52. And then we want our final answer in standard form. So instead of dividing everybody by 4, I'm going to move the 5x to the other side. That's going to give me -5x plus 4y equals -52. I don't want the leading coefficient to be negative, so I'm going to multiply everybody by -1. That's going to give me 5x minus 4y equals +52, and that will be your final answer. So again, it is a long process. It requires a lot of steps. You have to find your slope, plug it in. Sometimes you'll have to kill the fraction to make your job a little easier. Clean it up algebraically, get everything kind of organized, then go back and look to see what kind of final form you need. If you need standard form, make sure you follow the rules for standard form. If you need slope-intercept, it's a little bit easier. Alright, example 6 says write the equation of a line through the points 19, -2, and -11, 10 using what we call function notation. Now function notation is back from section 8.2. Function notation is f of x equals, which is the same thing as y equals. So when it says function notation, it's the same thing as slope-intercept form, except instead of y equals, we're just going to write f of x equals, but everything else is the same. So again, let's find our slope. It's going to be 10 minus -2 over -11 minus 19. That will be 12 over -30. Which, let's reduce that to make our jobs easier. I think that reduces to -2 over 5 if I divide them both by 6. So reduce your slope if you need to. It makes it easier to work with. So here's my slope. I'm going to pick a point. They're not too pretty here. I'm going to pick -11, 10. Does not really matter here. So y minus box equals -2/5 times x minus box. Let's see, the x value is -11, y value is 10. Oh, and the slope's -2/5. Sorry, I was not consistent there. This is y minus 10 equals negative 2/5. This is going to become x plus 11. Let's go ahead and kill that fraction so it makes it easier to work with. Multiply both sides by the denominator. On the right, it just cancels with the denominator. Nothing else changes. On the left, we distribute. So we have 5y minus 50 equals negative 2 times x plus 11. Make sure not to lose that little negative there. It's still there. Distribute your negative 2. So 5y minus 50 equals negative 2x minus 22. Bring that up here. Move that 50 to the other side. So that gives us 5y equals negative 2x. And then negative 22 plus 50 would be positive 28. And then we need to read what we want. We want function notation, which is y equals form. So I'm going to divide everybody by 5. So y equals negative 2/5 x plus 28 over 5. And the only thing to make it function notation is just change that y to an f of x, which does nothing to the actual equation. It just is a different notation. So f of x equals negative 2/5 x plus 28 over 5. Example 7, write the equation of a horizontal line through the point 2, negative 3. You might want to go back in your notes and review the facts about horizontal lines. Or sometimes I'll draw a little sketch to remind myself about horizontal lines. So if I draw a horizontal line, that helps me remember that it's a y equals value. It's y equals some number. So horizontal lines are y equals some number. In order for it to go to the point 2, negative 3, the y value has to be negative 3. In order for it to go through that particular point, it has to go through negative 3, which would actually be down there if we were going to graph it. And this equation seems too simple. That's all it is, just y equals negative 3. It's just whatever the y value is. The part you have to remember is that horizontal lines are y equals values, and that's easy to get mixed up. But horizontal lines are always y equals some number. And if you need a visual, just sketch a little horizontal line on a grid to help you remember that they're y values. Example 8 says write the equation of a line with undefined slope through the point negative 2, 6. So for this one, we have to remember what kind of line has undefined slope. And those are vertical lines. Again, a little sketch can help. Zero slope is when you're just not moving anywhere if you were standing on the line. Undefined slope is when you're trying to ski on something perfectly vertical and you can't stand on it. So you have to remember that an undefined slope is a vertical line, and that vertical lines are x equals values. They cross the x axis. So these are always x equals some number. In order for it to go through this particular point, it has to be the x value negative 2. And again, that seems too simple, but that's all it is. X equals negative 2. So there's 3 things to remember for horizontal and vertical lines. And you have to remember all 3 of them. You have to remember that horizontal lines are y equals values and that they have 0 slope. So you have to remember kind of all 3 facts about horizontal lines. Same idea for vertical lines. You want to remember that vertical lines are x equals values and that they have undefined slope. It's kind of like a triangle to remember. You have to remember all 3 facts interchangeably. Vertical is x equals is undefined is vertical in every possible combination. So it's kind of like a little triangle trio of facts to memorize about vertical and horizontal lines. They're very easy to work with, but it's a little bit of trickery to remember, and flashcards can come in handy for helping you remember those. Alright, I'm going to pause there, and then I'll record the last part of this section.